Hey guys, so this is a little extra bonus that is not in our notes that I have included online under this title right here with it's on Google Classroom with probability kind of as a subtitle because about a third of our test is going to be probability. And I thought it might be a good idea. You know, we've done a lot of proofs. Hopefully you're still going back and you're working on, what we know about linear pairs, them adding up to 180, vertical angles being equal, complementary angles adding up to 90 degrees. We know that if 1/3 is probability, 1/3 is going to be kind of chapter 1, linear pair problems, sup, adding up two angles and doing algebra, linear pairs, complementary, seg add post, all that good stuff. And then, of course, the last third of our test is going to be proofs. And so there's kind of our test split up into, if you like, 3 kind of separate pieces here. Okay, and so I really wanted to focus on this piece today, right before, we're going to be taking our test tomorrow. Or I guess if you're watching this on Tuesday night, or on Monday night, then here in a couple days. So real quick, let's hit up each of these sections, starting with mutually exclusive. Now, if you see the words mutually exclusive, that means you are dealing with the word or. And if you are dealing with the word or, that means we are adding and maybe subtracting. Maybe. And we'll see. We'll talk about that. So a jar contains 7 balls, numbered 1 to 7. So there's our sample space. 1, 2, 3, 4, 5, 6, 7. We randomly pick a ball. So we're going to randomly grab one of these spheres out of here. What's the probability that it is numbered 2 or 6? So the probability of drawing 2 or the number 6 of these balls. Well, what's the chances of drawing the ball that is numbered 2? Oh, well, that's 1 out of 6. Plus the chance of drawing the sphere numbered 6 would be 1 out of 6, would be 1 out of 7. 7 balls, right? Plus 1 out of 7. Now, here's the thing. Will there be subtracting? That's the question. Will there be subtracting? Well, is there any overlap here? Nope. There's not a ball that's both 2 and 6. So there is no overlap, which means we don't have to subtract. So you can just add. You got a 2 out of 7 chance here. We've got a 2 out of 7 chance here. Okay. Now, let's look at some that are maybe more independent. Now, independent involves the word and. It's whenever we need multiple things to happen, kind of simultaneously. And unlike mutually exclusive, where these two things can happen at the same time, and if they do, we subtract out the overlap, independent events can happen at the same time, and in fact, we want them to happen kind of consecutively. Now, because of that, we're going to be multiplying. So you should get smaller probabilities here. So take a look at number 2, guys. We've got a basket that contains 8 apples and 6 peaches. 8 apples and 6 peaches. Now we're randomly selecting a piece of fruits, and here's the key, we're returning it to the basket. So the amount of fruit resets after we pick the first one. It's not like we're going to be losing, our denominator is going to be getting smaller with each fruit we pick. Then we're going to randomly select another piece of fruit. Okay? So what are the chances that the first piece of fruits is an apple? There's our word. And the second piece is a peach. Ooh, so not only are we going to get an apple the first time, what are the chances that we then also get a peach? So the probability of an apple and peach. Well, what's the probability of getting an apple? Well, out of all the fruit we have, looks like 8 apples, 6 peaches, so we have 14 pieces of fruit. Okay. Out of these 14 pieces, how many are apples? Well, 8 are apples. Times, how many are peaches? 6 are peaches. So 8 over 14 times 6 over 14. And I'm going to give you guys a chance to multiply this out and see what this simplifies down to. So let's pause the video and give it a shot. So we multiply, we get 48 over 196, and when I plug that into my calculator and simplify it, that is 12 over 49. So not great odds, but honestly, a little bit better than I would have thought there. So 12 out of 49 that we get an apple first and then a peach. So again, they kind of told us what we were looking for there at the ends. And I just wanted to do one more with you guys before I let you try the last 3. Let's look at number 3 together here. Now this one's a little bit tricky. We have 4 nickels, 3 dimes, and 5 quarters. So 4 plus 3 plus 5. Looks like we have 12 coins to start. Now, we're going to randomly pick 3 coins and place them on the counter. Oh, shoot. So we aren't replacing. Unlike the last one where we put the fruit back, we are not replacing. So then whenever they ask us, hey, what's the chances that the first coin is a nickel? We say, okay, I've got this. So probability of the first coin being a nickel. Okay. I know that's going to be, looks like 4 nickels out of 12 coins. Okay. But then the second is a dime. Oh, okay. So nickel and dime. Well, we know that we have, looks like 3 dimes. The problem is we've already taken a coin out and we didn't replace it. So now that's 11. And then we say, oh, shoot. And the third is a quarter. So, and a quarter. Well, that's going to be, looks like we've got 5 quarters, but that's out of 10 coins now. And so you see what happens with each coin we get out, we have 1 fewer coin. So our odds are actually going to get better with each passing coin that we try because we have fewer coins in our pocket. So let's multiply these out. 4 times 3 times 5 gives us 60 over, oh goodness, this is going to be a huge number, 12 times 11 times 10. Actually, that's not as bad as I thought. 1320. And if you do this in your calculator, we end up with a, not surprising, 1 out of 22 chance. So not great, which is understandable considering we're trying to get specific outcomes for 3 different coins here. Okay, I'm going to pause the video and let you guys try 4, 5, and 6. And when you're ready, we'll double check these. We're going to have some and some more problems. So go ahead, guys. All right, so let's check this out, guys. Number 4, we have an independent problem involving and. So we take probability A, multiply it by probability B, and you find out that the chances of both these happening is 9 out of 40, which of course is worse than each individual odd because now we need both to happen. Next up, we're going to find the missing probability. So we know the probability of event A, the probability of event B. We know the overlap, the probability of both of these happening. Now we want to know what's the chances of A or B happening. So one or the other. What are the mutually exclusive chances? Now the problem here is we know we're going to have A plus B because we're looking for or, mutually exclusive, but we have to subtract the overlap. And so once you get what all of their common denominators are, looks like 20, 10, and 200. We can turn 20 and 10 into 200. And by doing that, you have to multiply this one by 10 and this one by 20. So 3 times 20 is 60. 13 times 10 is 130. You work that out. You get pretty good odds here for mutually exclusive, of course. 151 out of 200. Mutually exclusive is going to help our odds because we're cool with one thing or the other. How about last one here, number 6. So we know that once again, we have the overlap. We've got the individuals. We're trying to find the mutually exclusive. So we say, okay, we're going to do 13 over 20 plus 2 over 5, and then we're going to subtract the overlap because we can't count these chances twice. So I'm thinking, what goes into all 3 of these? Now, again, you could just do this on your calculator, but I'm thinking 25 and 50, they can all go into 100. So 100 plus 100 minus 100 there. Now, how do you get 20 up to 100? Oh, you multiply by 5. Well, when you do 13 times 5, that's going to give us 65. How do you get 5 up to 100? Oh, you multiply by 20. 2 times 20 is 40. And how do you get 50 up to 100? You multiply by 2. Negative 13 times 2 would be negative 26. So you do 65 plus 40, which is 105. And then you subtract 26. You end up with 79 out of 100. Almost an 80% chance. That's not bad at all. And so hopefully, guys, that was good for you to get some practice with mutually exclusive and independent. Thank you very much.